This is the original Houndbot. Navigation is done with a PlayStation 4i at the front. Custom CNC mounts, attaching it to actobotics channel. The wheels on each side are both driven by this RoboClaw here. The wiring, you see there's a white terminal block halfway down this dual actobotics channel, and cabling down here. It's a bit of a waste actually, I discovered, of having that 3-inch high, 18-inch long actobotics channel in the middle, and held apart, as you can see by some, or possibly see by some channel in the middle, so about 4.5 inch wide, but only having the cabling and terminal blocks in there, which then moves the computer up, which is actually on some slight standoffs here, but moves the computer up above the backbone. Center of gravity is sort of a little higher than it needed to be. Fused switch box here to run the logic side, well, plus the lights and a few other things. Custom upgraded suspension. Painted the little saddle mounts just to add a little flair. These suspensions are actually off a push bike, a mountain bike. Made the bracketing at the top, and I'm just running a threaded rod through the bearings and the saddle mount at the bottom. Too stiff for the weight of the robot at the moment, which is around 20-25 kilos. Originally had these trolley tyres, which I've then since upgraded to these larger little, well, they're 12 inches, so basically off a little kid's toy of some sort, but works out nicely in this application. On each side, underneath here, there's a little trough saddlebag with Velcro and foam padding, and that's where one of the LiPo batteries goes. And likewise on the other side, there's another easier to get to saddlebag. At the back we have a proper RC receiver and away from the metal 90-degree angle and air antenna. This is wired up directly to an Arduino, which just puts out messages over serial, so basically ROS serial messages. The entire robot's been switched over to run off ROS. On the other side, GPS if you wish to go GPS navigation way. And of course another little, you can see it at that angle, another little Arduino in there to send those messages forward, and the compass. And then there's an accelerometer in there as well. So the whole plan, that's just a DC to run something or other off the LiPos, which I can't recall at the moment. And at the tail end of the robot, USB 2 and USB 3 switch hub, switching hub basically. So the plan, this is the constant current controller for the headlights, which are 4 3-watt LEDs. A combination of heatsink compound and epoxy glued onto the actobotics channel, which seems to heatsink quite well and also hold them there. So the plan is to upgrade the shell from those 18-inch channels, and instead of how he is now, he'll be using this. And that'll be the new front and the back, about the same sort of width, and in the middle you have a carbon fibre Kevlar reinforced side, and underneath the lid will be where the computer lives, which will be a good 5 inches lower in the ride than at the moment. This is the start of the skeleton for the new Houndbot. The sides and the base is a single piece of 6061 aluminium. The sides were cut from a similar piece of 6061 1/4 inch. A hollow tube here welded on both sides to provide complete structural integrity at the top. Very solid welds placed on each side of this. The underbelly of the robot itself is not painted. Giving you some idea of the welding. The two pieces were placed at a slight angle at 90 degrees, thus giving the fillets of the weld a really good hold on both sides. Just a little bit of cleanup underneath, and that's what the aluminium looked like initially. Since the underbelly of the robot will only be seen if it happens to roll over and be in great distress, the painting of that part doesn't really matter. These 4 cylinders are welded on at the base, and you can see a little hole in there. Threaded rod basically going to come through from the bottom and attach a plate to sit over the computer there. The sides should be carbon fibre Kevlar reinforced, which is a next stage for the build basically. And of course drilling out 24 holes in these sides for the swing arm and the suspension to attach. Moulding for the backing on the carbon fibre parts. I've now put some baking paper over the spray glue and then baking paper over the outside of the MDF and the plasticine. Spray glue wasn't particularly, a bit cloggy basically. It didn't give as smooth a layering as I'd hoped for. And I can put PVA release agent on the outside of this and have some chance of getting the outer carbon fibre off again, whereas with no release agent the epoxy would just get lapped up by the MDF. And some PVA mould release. It turns out that it's a little bit less happy to go on baking paper than I'd have thought. Took 5 or 10 coats to stop it from beading up as much. And I think I've got a reasonable coating on the side here. Unfortunately the baking paper has bunched up a little bit now. Hopefully the 3 or 4 layers that I'll be putting on of the carbon fibre won't show that layering on the outside, but we'll see how things go. As you can see, this is sort of more the beading that it likes to do when you start trying to apply it. I'm just keeping a wet brush, letting it dry a little bit and going over it and over it and over it. After about half an hour you can get a sort of a more coated look. Now our first layer of carbon fibre is on the other side. I've just put on this side of the MDF backed baking paper and then PVA release agent. And as you can see, it's still a bit globby, but if you're persistent with it you can get a reasonable sort of coating over the outside. I don't know how well this is going to release or how much of the backing stuff I'll be able to get out once I've placed the carbon fibre stuff in place. It may be that I can only take some of the hot glued MDF from the inside. It may be that I can get most of it out again. I peeled off the MDF on the inside and the baking paper came away okay on these shorter pieces, but I think I let the outside cure too much and the baking paper has decided to stick onto the PVA release agent, which is still attached to the outside. The smaller bits are still a bit blue with release agent as well, so I need to work out how to try and get that off. These guys are really quite rigid for the smaller runs. The edges, one edge is more flexible than the other. This one's not bad. This one sort of has a bit more give in it than the other one. There is give at the very bottom down here, as you can see. So I think running a bead of, there's a little bit of give there too. Running a bead of some sort of clay epoxy or something like that, a little fillet along the bottom, just to hold that in place. I think there's still, with 4 layers, fairly little risk that this is going to break. There's a bit more flex in this side, but it's not really torsion wise. If you're trying to shove your fingers through and hear cracks or anything, that's not going to happen. So that's not too bad for a first attempt. We wrapped it around the bottom. I've got threaded rod coming through from a hole in the bottom, and this brass painted number will slot in and slide down and bolt on. It's not really as rigid as I'd like, but that will be probably replaced by anodized aluminium at some point. It's a preliminary test fit with the top piece of aluminium attached. Not a perfect fit, but a little bit of inner seal should, plus this is a little bit bowy. Not the final piece obviously, but gives an idea of what's going to be protecting the computer. Like you can see straight through the whole chassis from the front to back. So move the old head unit across, mounted it on these little standoffs to avoid scratching up the paint. And now drill out the base holes, which are a set distance in, set distance apart, and I think it's 27mm apart height wise. Use the same measurements from the front and from the bottom on all 4 sides. At the rear I've taken one of the wheels off and have now fitted it to, attached it, bolted it through. The 1/2-inch bolts are a little bit too long, so I'll have to get some slightly shorter bolts for that. And the main point of attaching this wheel is this part here, which is not actually bolted on yet, but I need to be able to adjust the height of the wheel to work out exactly where to, well, where I'd like some holes to attach these guys. I may end up drilling additional sets so that I have the ability to vary the ride height without having to take the whole thing apart again, just to re-drill these top bits. The main thing to work out is this clearance here, which I've got sort of about 2 fingers worth now. Obviously that clearance changes depending on where you're setting this tyre, if it's up a bit or down a bit. So it's okay now, but when you're off-roading it, you'd like to be able to make sure that it doesn't, there's no give in it or it's going to hit this. This turned out quite well, and there's a bit of flex in there. It's only attached it last night at the base here, bit of JB weld, and the front was a little too snug, so the JB weld attaches it to the back of the frame. On most of the other ones there's a little bit of additional wraparound, and that's epoxied to the upright, which makes this quite hard to move. But another 4 drill holes per wheel, and I may be able to attach them all. I also epoxied in the underbelly, and you can see it from this angle. This cable run, which will fit 4 cables, so I can run the cables from the back to the front to run the front motors, and put the, this will be the back, and down here I'll put the motor controller. The updated wiring for the RoboClaw motor controller, left and right both going to large high amperage terminal blocks, so that the 2 left wheels run off one channel and the 2 right wheels off the other. and a little collection of holes in the bottom. The 4 at the front are to attach the RoboClaw, and the 2 at the back are for the terminal block. And another small collection on the side. These 2 here are to attach a plate which will be above the motor controller on the inside. About to do a test fit of the RoboClaw motor controller at the back with the terminal block to see how well those holes work for it. So now all 4 wheels are fitted again. A few fun and games we had fitting them. These top holes were a little bit close to the, well, they were right on the front. They got nice clearances there. And the scarf actually kicks in a little on the bottom with some of these guys. I had an issue where one was a millimetre or 2 off and had to be filed, and for some reason one of the bolts became a little bit sticky and I decided to force it and snap it off, so I have to take off one of the wheels and this whole wheel assembly here, disassemble the wheel assembly to get this little thing out in here, which is where the bolt that comes through is snapped into it. So that'll be fun, but not the end of the world. These top guys here, this seemed like a brilliant idea at the time. I still like the look and the rigidity it's going to offer, but in underneath here, the kind of hard to get the angle right. You can see the heads of the bolts there, sort of interacting with the weld scarf. I probably should have got the flap disc Dremel in there and cleaned them up to start with. But it seems to come through okay, and I'll put the 4 little chunkers in here so that this can load in and sit above the motor controller once that's in. The motor controller holes are waiting for the pre-set up device to take its rightful position in the back. So we're getting almightily close now to a spinning of the wheels test. Alrighty, things are getting exciting now. A first time test. The robot's actually up on some blocks so the wheels don't make contact with the ground. The wiring is all placed in. I've left the under chassis wiring out of its tube because I need to do a little repair and change some of the bolts to smaller bolts before I finally mount the side suspensions on. So a few little scuffs here and there, but nothing major. Place the battery in. The computer's sitting over on the bench with the RC receiver and a hub and a few other things. Half the robot basically sitting on the bench plugged in. And my assistant will now begin rolling for the first roll test. The 2 front wheels are obviously going in the correct direction. The slicker rear wheels are all 4 wheels going in the right direction to move the robot forwards. Seemingly a bit of rubbing noise coming from somewhere too.
Go again.
And go reverse if you like. Brilliant. The motor controller in the back is just sitting with a few screws in its hole with 1 bolt on them, so they can be bolted in properly. And the tyres wonk around a bit because there's no air in them. And these wheels are actually slightly larger than they need to be. So all things are progressing. So we've now got the camera and ears mounted on the front, and the RC and the GPS accelerometer units on the back. All of the cable nest in the middle is going to have to be attached somehow to the plate that's going to sit above the computer. And there's 1 USB cable missing from the front to send the control signals to raise and lower and colour the ears. So things are now progressing once the little battery motor control has been placed in and is quite happy. And its battery lead has been fed through, ready to receive. and a little lid placed on for a second layer, so that whole back section becomes available for some other electronics. This will be where the snoveling mouth gripping region goes. Still got the old rear tyres at this stage, but that's one of those things that's easy to handle afterwards. So I've now got the computer mounted inside the middle of the chassis, and I've put the covering plate over. Had to drill out another bunch of holes. Didn't have to go to the extreme I did, but 6 holes for each. This, and 6 for this. Took the back plate off the fused power supply. Drilled through, so the screws go through this brass plate, through the anodized back plate of this, and actually thread into this. And these guys, having 6 on, are really not going to go anywhere. Sort of a lot more comfortable having the batteries sitting up here with a fair amount of inward clearance to stop things. You know, we've got these front bits here, a bit of clearance inwards here, so theoretically a branch could sort of skim through here and then spring back and hit the batteries, but they're a lot more protected up here than they were like underneath the saddlebags that they were in before. This back area where I'd placed that fresh piece of flat channel actually turned out to be where the, currently where the USB hub sits. So again, because it's mounted sideways, I could just go again and put another flat channel in above and still have a reasonable amount of space above where the hub is to put some other stuff. Somewhere in the order of about 4 inches. Unfortunately, I've for now used this as a stopgap. The cables are too long, so I need to put them somewhere, so they're all wrapped around this as a cable store. This comes up from the motor controller. This trough here is where the motor controller battery lives. The middle trough for the logic battery connector. Because the computer is now inside here, getting to it's not, well, it's not difficult. You just take the threaded rod, take the bolts off the threaded rod and lift the whole thing up. The downside is that you don't really want to have to do that each time, so I've busted out a little on-off switch to turn the computer on and off. And this thing here really needs to be bolted on as well, but I got a little bit impatient for a test run outside. So the lights are now just sort of stuck here, and it just races over here to the terminal block. Routed the PlayStation Eye and also the other data cable through underneath here, which runs around, skirts around this side of the computer. Underneath that DC-DC step down is sort of sitting in this corner in there, which turns out actually was powering the USB 3 hub at the back off of this fused power supply. Some things actually need that the power offered on the USB port is not great, so you get a point where this RC receiver can be detected by the transmitter, but doesn't work properly. So you start getting all sorts of alarms without the hub having power. So there is the current completed build. These threaded rods turn out to be quite a handy idea because I can now make a cover plate for this. I put another level on here, another flat level on if I want, but also just make a cover plate which will fully protect these batteries from any sort of nasty impact. This solution works out reasonably well. There's the compressed foam at the bottom, Velcro tabs, and I've glued Velcro to the battery, so once it goes in and has the 2 sets of Velcro tabs clumped over it, it tends to stay where it is, which is obviously what you want for the battery. Having it slide out or slide off the edge and hit something is far from ideal, shall we say. So that concludes the let's upgrade from just using 2 18-inch, well 4 18-inch actobotics channels, and how hard could it be to weld up some 1/4-inch aluminium and build a reinforced side chassis to help make the thing look better, help make the rigidity a little bit higher. when I took that chassis apart, I'd noticed a vibration that actually loosened many of the bolts. Some of the bolts had fallen off on the four bolt crossovers. So certainly if you're doing anything involving channel like that, or playing around with outside robots, the vibration exceeds expectations. So some thread lock of some sort would be a great choice, which may end up being what I go back and do with these. Now that I've got them fitted and working nicely, when I'm happy with them, I'll put a medium degree thread lock on them. Last thing you want is a wheel assembly to drop off during a run. So stay tuned, subscribe to the channel, and there'll be some more videos involving this robot. Does about 20 k's an hour. Once I upgrade the rear wheels, I think I'll find out at long last whether it can still fly through the air on a BMX track. So until next time, enjoy.